Gavin and Dean, welcome to class. The kiddos have been collaborating really quickly on test corrections, which are due today by the end of the day. So if you guys have your corrections ready, make sure you get them turned in. However, I've also gotten them started in the packet that I gave them. Oh, that both of you guys might not have gotten. It's at the front of the room in the tray if you guys need extra copies. They've been looking at example number 6. Example number 6 is an Alaska problem, and I gave them the hint that even though this does include somewhere, maybe not every single part, but somewhere it does include calculus concepts, they are not supposed to be needing to solve by hand the derivative nor the integral. So my question was to them, what calculus concepts are involved? What makes some of this AP worthy as far as multiple choice or long answer? And how to do the calculus without literally deriving or integrating by hand. And my hint was endeavor number 6. Alright, let's see what you guys come up with. I've caught Dean and Gavin up. We are in letter A with this big old nasty function, and hopefully you guys realize a calculator is required. Okay. Question. What parts of this do not involve any calculus whatsoever? The first one, because the first one is literally just well, how were you supposed to solve the first one? Plug in what? 120. Why 120? Why not 220? Or sorry, 2020? Or 420? Or whatever. Funny. Why not 2020?
Because that's when it's 1900 people.
Okay, so to keep in context the point of the problem, and the point of the problem is that we're talking about years from 1900. Good, so 120. So what should already have been in your calculator starting from letter A? P of t, right? So I'm putting in P of t just so I can go ahead and access it. I'm assuming you guys don't need me to model pulling up the graphing calculator and plugging stuff in. Did you check in your groups to make sure everybody had it plugged in appropriately and knew what they were doing, at least for letter A, right? 71 point, what is it, 57? What is e to the power of? You guys have it clear on your worksheet. E to the power of negative 516. And then we're plugging in t, which is 120. Wait, no. In the y equals, shouldn't we just be putting this with a variable? Right? Okay, so just a variable. And how do I use my calculator to not have to reinvent the wheel? Why not type it out here? Why am I typing it in y equals? I can use it again and again and again. True? Okay, so then how do you guys get there again? Okay, alpha trace is a shortcut. You could do your y1, or you could always do bars, y bars function. It takes forever, but it works. And when you guys plugged in 120, what was your analysis of that 781,217 point? Should you put a point? You can always put more than 3 decimal, never fewer. Why am I going to come back and make this an 8? Now, in the AP would be very nice. They would say something like the nearest whole number. But why am I rounding mine to the nearest whole number? Wait, no, is that literal population? Or is that like a million, trillion, or billions? Or is it just literally 781,218? How do you know? Not from the question. You have to look at the given information. What does it say? Exactly. It just says the population is given by where P is population. Oh, I see. Okay. I thought you were in here. P is population. Done. Not population in millions or hundreds or billions. Okay, so yeah, 781,218 people, right? Okay. Okay. What's letter B? Any calculus involved here? Algebra? How fast in algebra is only possible if it's aligned with a slope of n. Does that make sense? In algebra, how fast is only possible with a line with a slope of n. So technically calculus is true, because how do we do how fast is something that's curved? you plug it into the derivative, sure. Now, I said you technically weren't supposed to solve any derivatives by hand. Now, how could you have interpreted that? What were you going to do?
Derivative.
You can use the derivative function on the calculator. Would that be solving for a derivative by hand? Not technically. So, okay, you could have totally used your math, and you could have, well, hold on. Isn't there a shortcut with the alpha also? What's the shortcut to get you to a derivative? Alpha y equals? Nope. Well, yeah, but ultimately alpha window. And then you could have done your derivative of d dx, and don't you have your nice little y1 alpha trace in there? When x equals 1920. Oh, 20 years, no big deal. Did you guys get that p prime of, are you labeling everything appropriately? 1,678. I could put decimals, but I'm going to assume that they wanted this all rounded to the nearest whole person that they would have told you. People per what? Yeah, good. And then what did you have to do for the other ones? Yeah, same thing with different numbers. And the nice thing is, can't we just go up and steal and then plug in, right? Just copy and paste. And then just change it to B40. Copy and paste. You guys know what I'm talking about. Go back and steal it. So we have 4,128 people per year. And then we have 9,741. 42, technically, provided the nearest whole person, people per year. And double check, hold on, pause. Is everything matching up? I did the same mistake. It's supposed to be a 2. Okay. Good so far?
Is this sufficient enough to write like p prime 20, or like do you have to label like more?
Well, they didn't tell us anything about explanation of what it meant in context of the problem is what the AP likes to do. So right now we're just answering with what the calculator gave us because it's a calculator problem, no work necessary. P prime is just describing the math that was done. Because that way if we were to make a mistake, and let's say they were to give you a point for using the derivative, you would get that derivative point even if you would miss the answer. And then we have our units just because always units true. For letter C, so it's more like showing work code. Not typing out the buttons that we use, but if we are doing a derivative at 20, 40, 90. So what seems to be happening with the population of Alaska between at least 1920 and 1999? What seems to be happening? And increasing at what kinds of rates? Well, I was thinking of what the trend that seemed to be happening. I mean, we could have done at 30 and at 45 and at 70. We could have even graphed P, right? But what seems to be happening to the rates? Increasing. So P is increasing, yes, they're all positive, but also increasing at increasing rates, seemingly. I mean, that's a very broad statement. But it seems to be that P is increasing at increasing rates. Now, do you think that's always going to happen? Yeah, we can check. Why don't you guys go ahead and check out what's going on at 2020? That's the predicted population. What's happening at 2020? What would P prime be? I know they're not asking it, but I'm asking it. So it would be P prime of 120. What would you guys get?
5,940.
Ooh. A, what's happened seemingly, and B, why does that kind of make sense? A, what's happening seemingly? The population isn't decreasing because technically we're still having people be born, right? But the rate has decreased. So it's like, hey, Alaska's growing, 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 but at faster, right? Steeper, steeper, it's growing faster and faster and faster. And why is this logistic? Why are they using Alaska as an example? Or I guess they could even be using the U.S. Is there any sort of factors that might cause the population growth in Alaska to be slowing down? Okay, usable space, maybe like interest in where you want to live and why you want to live somewhere, right? Maybe there's a lot of people that flooded to Alaska to try to, I don't know, there are some good, like on the fishing boats and stuff, you can make some good money. I know some kids that have gone like summers of college and they've made really good money out in the fishing boats, but man, it's hard work. But anyway, coming back. Families could have gone and settled there and had kids, but what are the kids doing? They might not be staying. And if they're not staying, they're not having kids. And if they're not having kids, fewer people are, right? Does that make sense? There are fewer people to help the population growth grow. So are they growing? Yes, they're growing. But does it seem to be they're growing at a slower rate? Yes. Anyway, hey, practical application of logistic growth. Hey, like it's all the rage, it's all the rage, it's all the rage. Or different factors also. Wait, why could population growth be slowing down all over the continental U.S.?
There's more people who can have kids. All the adults who die.
Okay.
Or you can't have less kids. I mean, that's like logical, isn't it?
Okay, I'm hearing you. A lot of babies, it takes time for babies to have kids, but think about who were the babies that would be having kids. Okay, no, that's a cultural trend, isn't it? More and more people, yeah. The different generations are changing because some people don't want to have kids, or maybe health complications, weird stuff going on in the U.S. can't have kids, or fewer people getting married, or more and more kids that would be had are not being had. You know what I'm talking about? Right? More and more easier birth control methods and different things like that, right? And day after pills and all that sort of stuff. Like kids that would have been had are not being had or not wanted. Anyway, culturally, it might not just be Alaska, but anyway, long story short. Question. According to this equation, and when we go to letter C, technically calculus has been done, but has it been super amazing, stupendous, kind of creative, or is it just like a plug and chug so far? Plug and chug. No analysis. They're not asking any of these questions about Alaska. So, okay, fine. Letter C, what's going on? Of what? Ooh, the maximum rate. This is starting to get a little interesting, right? Taking a little bit more creative effort. So if I need to find the maximum of the rate, what does that look like on my, so far all we have is, we've gotten P prime of, but I told you no derivatives were supposed to be found by hand and no integrals are supposed to be found by hand. Can you find derivatives on a calculator without doing by hand? Yes. But when they go asking for the maximum rate, can we graph P? Could we graph P? Yes. And what have I already kind of hinted at? And you can kind of tell from this looking a lot like this, what kind of shape would P have if we zoomed out to enormous amounts? What would P look like? Growing, slowing. Still growing, but slower. With the horizontal asymptote. Where is this fastest rate going to occur? Graphically, what is occurring at the point where the growth has reached its highest rate? Concavity is changing at that point, right? So it's like concave up, the slopes are increasing, and then concave down, the slopes are decreasing. The rates are increasing, the rates decrease. Where's the maximum rate? At the point of inflection. So why not agonize over getting a good window and getting that nice logistic curve to find the point of inflection? Because our calculator can do that. Second trace, what can our calculator do? Value, min, max, intercept. Derivative integral. Does it do a point of inflection? But how? Have you used your calculator, or should you have used your calculator, in the past to find a point of inflection? Find the derivative by hand, graph the derivative, and what is a point of inflection on a derivative graph? Relative maximums and minimums, where the derivative is changing from increasing to decreasing or decreasing to increasing, right? And can the calculator do maximums and minimums? So if I can find maximums and minimums of my derivative, but wait a minute, Lorenzo just said we had to find the derivative to put into our y equals to find the max and mins. What did I tell you weren't supposed to do? So how else do we figure out when Alaska was growing the fastest if we're not supposed to find a derivative by hand? Oh, the endemic card. I told you it was a thing. Could we go from here and cheat and figure out what the derivative is without actually solving for it by hand? Oh, that'd be cool. Let's do that. But wait, is this the derivative I could put into my calculator?
No.
Why not?
There's like 3 different variables.
Okay. There's 3 different variables, but pause. These variables, L and K, and C's, aren't they numbers right here? So we can figure out who L is. We can figure out who K is by process of elimination. We can figure out who C is. We can plug in L and K and what would we still have? Why is it bad that my differential equation is in terms of y? I would need it in terms of its x, which is t. So is this a form of the derivative? Yes. But is it a form of the derivative that I could graph in my calculator without going to parametric mode? No. To take this derivative by hand would be quite intensive. To go this direction would be great, but I couldn't graph it and find the maxes and mins like I could of the quite intensive derivative. So maybe there's a great clue that we should use in memory. When will any logistic growth curve be growing fastest? When the y, wait, who's the y in this problem? P of t. When the y, the amount, the P of t, is half of the carrying capacity. Hey guys, who's L? Lyse minus glyph. Who's L? 895,598. What is that?
447,799.
So what Kevin's saying is we should go ahead and take that P of t and say, hey, when are you half of the carrying capacity, aka when are you half of what seems to be the maximum population that Alaska would realistically? Which, how that's determined, I have no idea whatsoever. But as you guys brought up just a second ago, there's only so much usable living space in Alaska, right? It gets quite cold.
Sunlight, midnight.
In summer. It depends. But they also have, like, aren't there days where it's like 24 hours of darkness?
Yeah. On top of that.
Although I have a friend that lives there, and she seems
What is that?
Hold on, wait! Wait! You guys are slowing down! Hold on! Oh, you're like a logistic curve. Anyway, coming back. Still hopefully increasing, but slower and slower. Abby, hush! Are we done?
No.
Because what is it asking for? What the population is? When? Oh, so what am I supposed to find? T? Ugh. How do I find T?
Oh, so that means.
How do I use my calculator? Come on, this is a key AP skill. How do I use my calculator to figure out when a y value of function is another value?
You make that a line.
You already have this in your y1, right, guys? This is in your y2, true? So if I have y1 and I have y2, don't I just need an intersection? Oh, gross. I'm going to have to move my window to be up 400-something thousand? What makes everything a little bit easier? Why don't you bring it down to where you want it? Do you guys want to go looking for y as being 400-something thousand, or do you want it right around that nice little x-axis? How do we get it around that nice little x-axis? I need it equal to 0. How do I get this equal to 0? Why not graph y1 minus y2? Because you can do that. Y1 minus y2 has to be 0. That's when intersections occur, so why not? Go team. There's my y1. My y2. Well, why not just do y1 minus 895,000? 598. All over 2. And I don't really care about that old graph, so let's get rid of him and deselect him. I just want that new graph, and I want that new graph's intersection with the axis. Except, hold on, wait a minute. My t's, weren't they 20s and 40s and 99s and 120s? Do I need to make my x min and x max, so at least x max be a lot bigger? So, okay, change your window, x max, I don't know, go to like 200. It's bound to hit somewhere in 200. There he is. Now mine's like a weird straight line, kind of awkward, but did he pass through the axis? Can I use my calculator to find the 0 of a function? Yeah, I can. Just look at your y's. You need your y's to go from positives to negatives. Oh, wow. I was way off. There he is. Negatives to positives. Oh, he's actually going from negatives to positives. He's going up to the x. Not negative. Positive. Did you guys get 82.765? That would be years. So when? Well, when would that be? 1980s? 1982-ish, right? Are we figuring out exactly what month and day? No, we're just saying in the year 1982 in the context of the problem. True? What's going on letter D? We've already talked about that, right? The Alaskan population, is it going to keep on going faster and faster and faster and faster and faster and faster throughout all the time? Yeah, it's going to slow down. Could it keep growing? I mean, theoretically, I guess it could start decreasing depending on environmental factors, societal factors, but anyway. Let's not really stress about letter D. Where was the good calculus? C. However, what's the purpose of endeavor number 6? Simplify our lives. If they ask us logistic growth, they are not expecting us to actually take a derivative of a lice minus lift. I mean, that's a quotient rule, and that's an e to the power of, and we have to know. We're not taking this derivative by hand of a lice minus lift. Similarly, we're not integrating the crazy partial fraction stuff that you guys didn't like yesterday by hand. If we can match up a differential equation with the pattern of logistic growth, we can go straight to lice minus lift. And if we can match up an original equation with logistic population, then we could go ahead and think about the derivative as well. And we have a couple of tricks, like, hey, if they ever give us a limit to infinity of logistic growth, it's always L. It's always the carrying capacity. Or if they ask us something like, when is it growing, or when is it even falling the fastest? It's always going to be at half of the carrying capacity as well. Now, is this the only type of word problem you could ever see? No, but it was a cute way to start. What do you guys see in number 7? P.S. Do you guys have bookwork in this section? You do, right? This is an actual section in the book, 7.5? Sure. Okay. Is bookwork helpful for getting the main idea of a concept? Is bookwork helpful for getting the main idea of the concept? Yes, but doesn't help us for the AP necessarily. So what else do you need to see besides bookwork logistic growth? Because it's something new and something that can get tricky and where word problems and parts of FRQs might get involved. Multiple choice questions, right? Now we're not doing AP class on this just because we don't have time, frankly. We're trying to get to our test, which tests the main concepts of Chapter 7, the main understanding of Chapter 7. Not necessarily the AP coverage of Chapter 7, but do I want you guys to have multiple choice to be playing with? Yes. That all needs to be done by Friday? No, not necessarily. But it's going to be due after Thanksgiving break? Oh, yeah. Okay, what do you guys see? In this problem, how is example number 7 different? They give you the rate equation. What kind of rate equation? Ew, a rate equation where there are y's inside. Could we divide not just this y expression, but that y expression to the other side and do partial fractions and take a long time to integrate? Yes. But does this fit one of the 2 logistic growth differential equation patterns? Which one? Is it the LK one or the K one? How do you know it, Lainey?
Because inside the parentheses it has a number that's not 1 minus 3.
Now, it is written right above, and some of you might have just guessed it. But can you look on your endeavor card really quickly? And I wish I had it on the wall. I really wanted to get it all done last night, but it just didn't all happen. Look at your 2 different differential equations. One of them has all nice, in a sense, let's just say whole numbers, and the other one has a fraction. Does this one have P over anything? No. So it fits this pattern. True? So if we were to start plugging in stuff, then question, from this, what is my K? And what is my L? So if they were to ask me the horizontal asymptote of P of T, are they actually expecting me to take an integral and find the original equation and then take a limit? No. They're asking me to say, do you see that it's logistic growth? What's my carrying capacity? 100. So this wildlife preserve, it can sustainably not go past 100. Probably not even hit 100. 100 seems to be where they'll never go beyond. Oh, so letter A, what's the carrying capacity for bears in this wildlife preserve? Guys, that would be such a loaded question if you didn't have endeavor number 6. Because without endeavor number 6, literally, you have to separate the variables. You have to do that partial fraction integration. You have to find the original equation, given a clue that you don't actually have to find the plus c, and then take a limit to infinity. Huh? Instead, we can say, oh, it's easy. Hey, look at L, and L is 100. Da-da-da, 100 bears. Bears. Oh, you guys haven't seen that. That's hard. What is the bear population when the population is growing the fastest? Loaded question. Fastest, the maximum derivative. Uh-oh, you take the derivative of the derivative, the second derivative, and then probably the third derivative, so I can use the second derivative test as to whether or not the critical numbers, or just realize it's logistic growth. For what population, not when, but what, for what population, guys, is this thing going to be growing the fastest? L over 2, aka 50 bears. Now hold on, are they asking what population or are they asking when? Because the what population was super easy. Oh, look at it. What is the bear population? Okay, 50 bears. L over 2. If they ask the when, what would we have to do? Plug it into what? Plug it in as P, but no P, so have to anti-derive? Oh no. Whew, good thing they're not asking us for when. Letter C, what is the rate of change of population when it's growing the fastest? What is the rate of change of population? What's that? Wait, you guys, come on, you're smarter than you're acting. Rate of change of population. Rate of change of population. Derivative, P prime. dPdt, it's right there. Huh. All I have to do is dPdt, differential equation, such that P equals 50. And guess who the only guy is that I need to know to plug in? And we're amazing. We're not going to actually put this in our calculator and accidentally make a mistake. We're just going to plug it in and say, stick it to the man. Bears per, what are my units? Now, hold on. Letter B says, when it's growing the fastest, what is the bear population? Easy, L over 2. Letter C says, when it's growing the fastest, what is the rate of change of population? dPdt, easy, plug in. Letter D, what if they were to ask you, which is a great loaded AP question, what if they were to ask you the when? They don't say when and then actually ask for something else. But they actually want the when. The one question, even though it's been in each of these, the one question that hasn't been asked yet. When, what's the bear population? 50. When, what's the rate of change? That mess. But they haven't actually made us find the when. Why? Why would that be at the end of an FRQ or at the end of a series of questions? Because it's the hardest one. Why is it the hardest? We've been saying when, but answering bears and answering how fast. What do we need to do again? Find what? We need to find T, and where's T? Is it in the differential equation that you guys have up there? Nope. So, what do we need? But I just said you're not supposed to integrate these by hand. How do you use endeavor number 6? When an integral is necessary, when we need to go from a P prime to a P, how do we use endeavor number 6 to get exactly what we want? Right.
It's the T of when P double prime of T equals 50. Or when P double prime of T equals 0.
Okay, so we could try a product rule. We could see what happens. It's not what I was originally intending, but we could try that. So Brian's saying, wait, it'd be the maps of the rate, which would be when the derivative of the derivative is a critical number, because these are smooth terms only, not sharp. So we could go ahead and do a product rule. And the product rule, we would get second, which we could plug in, P is 50, D first, which would be 0.008, which would be a dP dt, plus first, which would be 0.008. I could plug in dP dt because I just found out what that was. First, D second, which would be negative 1 dP dt. Is that equal to 0? So let me see a dilemma with that strategy. Mathematically, I understand what you're saying, and you're right. The second derivative would be 0, but what's the problem? If you plug in the dP dt's that you already know, and you plug in the p's that you already know, do you know what you would get? 0 equals 0. There's no t. It's a good idea, but there's no t to be found. So the differential equation of logistic growth is solely defined in terms of the original population. What do we have to do? Memorize endeavor number 6 that says, I'll always help you go back if only you remember the pattern. Question. Can you figure out what L is from up there? What's L? 100. 1 plus C. We'll get back to that. E, the negative. What's LK? So we move it 2 decimal places. Careful. 0.8, right? Are we still in a little bit of trouble? Why? Now we're better. We have a T. Should we be able to use algebra or a calculator to find this guy? Maybe subtract the 50, find a 0, or find an intersection. But what's the problem? We have a T. Why would there be a C that we don't know? We just did integration. We cheated integration because we knew what the answer was going to be. But for any integration, for any going from a differential equation to an original, what else must you be given to make it possible to solve? An initial condition. And what did they not tell us? We don't know any time with any fair population. So what don't we know? C. We have no way to find C. If we knew a P and if we knew a T, we could plug in, we could find C, and then we could ask this question. So technically, is this a possible question? No. But do you see how it would be possible? What's the one thing they would have to tell us where it would be possible for them to ask? Yeah, give us an initial condition, and then we would go straight to lights minus lift, and then we would go ahead and solve for the C, because we would know this is P of T. With one time and one bare population, I could know C, and then I could find the T when it's growing the fastest. They love asking this question. There would have been an initial condition, but hey, it made it more interesting to say, what if this was there, and why is it not possible as is? There's a C, and that C is the constant of integration. Anyway, moving on. Guys, you have other examples, and we could play with the other examples all day. But I was looking for... What was I looking for? Ah, here we go. Can we check out this? Let me zoom in a bit. Free response. If we had like 1,010,000 extra days, we would have done all those examples in between, and we would have finished that whole worksheet, and then we would have used that homework. I mean, it's good stuff. If you guys have any questions, you can let me know. But why am I zooming in on us analyzing this guy? Who is this? It's the other form of logistic growth. Do you see it? So this one would be fitting into it, because they can give us either way, and they do give it to us either way. So we would have to, and you have to, memorize endeavor number 6. Realize that there is another way of talking about logistic growth. The differential equation of logistic growth. Does that help to know that that fits into that pattern? Okay. So what's going on at A? If it says P of 0 is 3, they give us an initial condition. Uh-oh, they might ask something of us soon. P of 0 equals 3. What's the limit as t goes to infinity? Wait. Why are we just going to answer 10 real quick? Not just that one, but also this one. L is the carrying capacity. Carrying capacity is the... But is anybody confused by the 20? If 10 is the limiting capacity, if 10 is the highest it can go, are horizontal asymptotes always the highest it can go? Or is it just what it approaches? What's this going to look like if I have P of 0 equal 3? Hold on. When is this going to be growing the fastest? When is this going to have a point of inflection? At 5, right? Okay, so 3, and then there's 10, and then there's 5. So it is going to have a little like concave up, and then it's going to be concave down. Because it has to go concave up to that point of inflection and then change. How about 20, though? It's decaying. There was too much population growth. The land couldn't sustain it, so then they're all dying off. Silly example, and I'm not a scientist, I'm not a population researcher, but does that kind of make sense? If you go beyond, you're going to come back down to, or if you're below, you're going to go up to. A horizontal asymptote doesn't have to be the highest. Sometimes it's the lowest, just so that doesn't confuse you. But what's going on in letter C? Ooh, if you saw that before we talked about any of this year, wouldn't you guys have gone like separation of variables and playing with an integral? They give you a differential equation. They want an original. They give you a clue. So how are we supposed to make it? Can we do lice minus lift this time? Because they give us a clue. So therefore, who's my numerator? Lice minus lift. L is 10. I still don't know C, but I'm going to find him in just a second. Who's L? 10. Who's K? What's L times K? Oh, lice minus lift, LK. Instead of finding them separately, why not just say 1/5 is LK? If you needed to find K, though, you would have had to set 1/5 equal to L times K. 1/5 is equal to 10 times K. Divide by 10. K is equal to 1/50th. Let's just plug in L and K all at the same time. And then we have our T. What would you guys be able to do in one quick step? Well, we could do it now if we wanted to, but what do we need to do to finish off our original equation without doing any by hand integration? Plug it in. We know this is equal to, oh my goodness, are we going to need to know pre-cal? We should sue. 10 over 5 is 2, that's going to be a negative 2. I guess you could go ahead and do a multiplication and a division and a subtraction and eventually ending to an ln, which will find you your C. And once you have your C, you could plug in. But what's the limit going to be no matter what? Even if I couldn't do the function? The limit's still 10. That's funny. Could this homework be ridiculously hard if you don't use endeavor number 6? So what are you going to do? And if you're like, I need some more rigor to this homework because the book work or the book's coverage of it is so, whatever, elementary, you have nice AP multiple choice questions to play. But technically, for Friday, what probably should we stay focused on? The main concepts reviewing for the chapter 7. Yeah? So Friday, remember, it's not an AP test, it's not AP coverage, it's main concepts. But play with the homework, you have some multiple choice to start if you want. But my advice at your time is, bye guys. What? Never, number 6.
I'm not going to be
Just bring your little locker with you. I'm sorry.